let me now introduce our speakers for today. First, we have Herman Huytema. Herman is a VM product manager and has worked at Nortek since 2003. His focus was initially on the use of ADCPs for discharge, but now he works with all kinds of applications. So presently he's a product manager as well as a senior sales engineer for Nortek's vessel-mounted current measurement solutions. Our second speaker today is Maeve Dougherty. With a background in water resources engineering and marine science, Maeve brings a geosciences perspective to data analysis. She came to Nortek BV in July 2019 after working with HF radar data and CTD data. Prior to that, she also analyzed rivers, floodplain, and wetland systems. So we can now start this webinar, and the floor is yours, Herman.
Thank you, Rose, for introducing me and Maeve, managing this webinar today. Also, special thanks to GeoPlus, who let us use this picture of their background on the background. It's the vessel, the Geo Ranger, the new vessel of GeoPlus, whereof we can proudly say that it's actually equipped with one of our signature VM ADCPs. Let us start straight away with the presentation. When we look at today's trend, there is the tendency to go further and deeper offshore, where you need larger vessels and other equipment as well. A gap typically filled by lease vessels and lease instrumentation that requires lots of time and energy to mobilize for the job. Reflecting this to ADCPs, you require a unit with an intermediate range to cover the greater depth. But this intermediate VM ADCP will never be on the CapEx investment list unless it can do multiple things and can also be used in other projects. This in practice means sourcing a rental unit and pay for whatever is available. I've added some nice history over here on the right side. And please let's hope it's not your lease unit that you will get at the end. It's actually one of the pioneers in measuring ocean currents. It's a picture taken a while ago, back in 1936, showing the Norwegian oceanographer Harald Ulrik Svendrup performing one of his current measurements. We just reflected the needs of the operational sector going further offshore, but as a biologist, you have other interests and other issues as well. You are interested in the upper layer, the biologically active zone where light can still penetrate. So as you can see over here, that's typically the epipelagic zone. So the Nortek and oceanographic epipelagic zone, which is roughly 200 meters. Well, the typical long range ocean units that they have, up to 1000 meters, they don't provide the spatial resolution nor the velocity precision required for this upper layer. So those scientists require an intermediate range instrument for this job. So if you want to recapitulate this into an ADCP wish list, we can say you need, well, a versatile ADCP unit that can do more than VM measurements alone, and it's something is worth to invest in. A system that has all required components in one box, something that you can quickly ship around and mobilize by your local team over there. A system that can be mastered by non-surveyors, so they can do the job. And for scientific purpose, it needs the right spatial resolution, and it needs to deliver precise data over a 200 meters range to cover the epipelagic zone. And of course, you want to have the best data that can be obtained from a moving platform, as well as data that is easy to interpret and can be quickly shared at the end of the day with the onshore contractor. Well, by the way, please let me know in the chat if I missed one of your wishes, and let me know. Maybe we can discuss them later on. Let's try to reflect the former slides against the signature 250 over here. At first, I will give you a short introduction on the versatile opportunities of this standalone instrument. It has 4 beams, which you can see over here. Those are the yellow transducers, and they're able to do a range up to 200 meters maximum. And there is a center transducer as well, which is a 500 kilohertz center beam, which allows you to measure wave height and direction up to 150 meters below the surface. So typically you mount this instrument in a subsurface float or either on a bottom frame. The same unit can also do ice tracking and ice thickness measurements during the winter. And also, of course, the stationary instrument can also do VM measurements and vice versa. Also, there is an optional fast sampling HHRS motion sensor, which makes it an ideal instrument for dynamic platforms. So you can mount it on buoys or on the smaller vessels as well. Let's talk about the signature VM, which is divided in 2 series of instruments. At first, we have the coastal series available in 1000 kilohertz, and we have a 500 and a 200 kilohertz frequency. And they give you a high sampling rate and a good single ping precision, which is important to obtain good data from smaller dynamic moving vessels. Ranges are respectively 30, 70, and 190 to up to 200 meters for the 250. The Signature 1000 and the Signature 500, they also include a high spatial resolution echo sounder that can be used for sediments and biomass detection. As said, besides the coastal series, we have also the long range ocean series, which include the Signature 100 on the left, and that has a 400 meter current profiling range, and also has an optional 5th beam, which is a biological echo sounder for biomass measurements. On the right, we see the Signature 55, which is a dual frequency instrument and can do 55 kilohertz as well as 75 kilohertz. On 55 kilohertz, we have a 1000 meters long range, and on 75 kilohertz, we have a 700 meter long fine profile. Lots of figures on this slide, and especially for the technical viewers, but what's important to note over here is that on a vessel, you want to have as much and as precise samples in time because of your moving. The 250 provides not only more range, but equals the precision due to a higher ping rate compared to the slightly higher frequency ADCPs in its class. And if we circle back towards the first 2 slides of this presentation, we want to have something quick and easy to install and to be operated by the local team. So how do we create the right environment to do a quick installation job, being able to set the configuration and data acquisition without any specialist, and can still guarantee optimal data? Well, the approach is to deliver a system including a cylinder-based, which I'm holding right now in my hands, as you can see. We deliver a cylinder-shaped mounting bracket with the instrument within the package, which can be used for over the side poles, as well in moon pools, or even to mount it directly onto the hull. So as you can see, it has a bracket, a stainless steel bracket, which slides over the instrument, can be mounted onto the head of the instrument, and at the back side of the bracket, there is a flange which can be mounted and bolted onto the pole. As well, there is a hole to guide the cables through. And as you can see on the end of the ADCP, it has 2 straight fitted connectors on the back plate. That's the bracket. but also we deliver a GNS within the package. And good time stamping is often neglected, but it's very important. So we deliver a true heading Ethernet GNSS, which allows it to be used as a master clock within the network. And it uses accurate Ethernet PTP protocol for this. And it runs within microseconds. So it's able to synchronize the Ethernet ADCP and to synchronize also the computer and the heading data all together within microseconds. On the right lower part over here, you see the processing unit, and that's actually the spider in the web connecting and powering the sensors and also running one dedicated process, and that's the acquisition software. More on the acquisition software during the next slide. Last but not least, we also have, or we also need the signature ADCP, of course, in this package. So last year, before its introduction, we performed a series of test measurements in the Oslofjord. And an interesting file to display here to offer a sneak peek into our convenient to operate acquisition software is this line. It's measured using a high resolution 4-meter cells, still having around 140 meters of valid range in a clear Oslofjord. Unfortunately, there was hardly any current, even not in this narrowed section. And a little bit background on this location, it only has like 30 centimeters tidal amplitude. So currents are never going to be above 10 centimeters over here, unfortunately for us. Good observers can also see a layer at 80 meters of depth, a layer in the opposite direction, which carries much more acoustic scattering material. This section also becomes larger over the tides. And as you can see, the incoming flow enters the fjord at this way, in the opposite direction. Let's learn more on the data, and let me hand over the presentation to Maeve.
Thank you. In September 2020, Nortek China deployed a signature 250 using a vessel-towed unmanned surface vehicle. And this test was deployed in Bohai Strait, which connects the Bohai Sea and Yellow Sea. Bohai Strait has a seabed comprised of sand, silt, and clay. And for the 6 tracks and the 8.5 kilometers sailed, there was valid bottom track for 99.95%. The cell sizes are meters 6 and 8, and based on the results of this test, the 2-meter cell size was an optimal balance of resolution and quality, where the 1-meter cell size was a bit noisy and data with the larger cell sizes had an over-averaged coarse appearance. And so this is data from a 2-meter track, and you can see the velocity in the top panel. We've got depth on the y-axis, ensembles on the x-axis, and velocity in the color bar, where the average current speed in this track is about 0.5 meters per second. So I've applied an averaging period of 6 seconds to reduce a little bit of noise that was in this data. The seabed resides at about 60 meters, and you can see the velocity range goes down to about 50 meters. And the amplitude and correlation meet the required thresholds. Then in March of 2021, Nortek Netherlands performed a double deployment of a signature 250 and a 1000, resulting in no interference. You can see the setup for this in the middle panel. And the vessel that was used for this deployment was the Water Wolf, shown in the third panel. So the Noordzee Canal is a navigation channel between Amsterdam and the North Sea. And for the 4 tracks and 18.5 kilometers sailed, we saw 100% valid bottom track. So for these shallower waters, cell sizes of 1 2 and 2.5 meters were used. And the 1 meter cell size was optimal here. So you can see that the velocity in the top range. You can see the long, narrow navigation channel, and I've trimmed it down to isolate the straight portion of the track. It's about 7.5 kilometers remaining. I applied a slightly longer averaging period of 12 seconds because of the noise of this higher resolution data. The seabed is around 14 meters. The velocity range is down to 12 meters. And you can see that the amplitude and correlation meet thresholds, and they have a few data gaps. And these data gaps were addressed in the velocity, which is the output we really are concerned with, or that we use through averaging. And I will hand it back to Herman.
Thank you. Yeah, so when we briefly summarize the Signature 250 presentation, we can say it's a versatile ADCP, which offers multiple functionality during stationary use and can as well be used as a vessel-mounted instrument. The faster sampling rate and combined range turn it into an ideal instrument for moving boat measurements. And the package approach simplifies and speeds up the shipping and installation. It has a modern and convenient to use acquisition and review software that can also be used by non-surveyors. And by simplifying the installation and operation, the chances of successful measurements during expensive offshore operations can be significantly increased. Using today's technology components as the GNSS master clock and as well as the fast sampling internal HHRS motion sensor help to optimize the final data quality of the whole system. Want to learn more? Well, we are making 3 consultancy calls available free of charge on a first come, first served basis. These personalized consultation calls are available for those who have further questions and are looking for the best measurement solution to meet their organization's needs. Also, during COVID, the VM demos have been difficult to perform. We soon hope for all of us that this is about to change soon. You can quickly or you can inquire for the next VM event at your local Nortek subsidiary or send me a personal email as well. As a second option during the COVID, we offer the opportunity to trial yourself with one of our VM coastal demo units. You can send your request either to a local subsidiary or send me an email. I want to thank you for your interest so far. And are there any questions that you want us to ask directly? Please let us know via the chat box. Thank you. Well, so far, I guess we did well. Do you see any questions, Maeve, incoming as well?
I don't.
Not yet.
Not yet.
Please don't be afraid to ask some questions over here. Ah, they're coming. Yes. Do you start?
Sure.
Maeve?
The first question, what is the maximum speed recommended for towing? That's a great question. I don't have the answer to.
Well, for the I can explain that one for the velocity for the VM measurements, and that's typically 6 knots. So that's 6 knots survey speed. And if you're towing something, I'm not sure if you refer that question towards the USV, but that's something I'm not sure about. I guess that is less.
Well, maybe the question came because the example that we had from China.
Maybe you can further explain that, Carl, to us, if we have answered your question already.
So the sales speed for the China deployment, just as a matter of interest, was about 0.8 to 1.3 meters per second. Sorry, that's not knots. So, and that was a successful deployment. So I wouldn't say that's a maximum, but I would say that's an example of a successful operation.
Thank you, Carl. Yeah.
Thanks.
Then we have a second question coming from, and that's assuming the processing unit will work with any manufacturer's GNSS antenna. Well, we have chosen the advanced navigation antenna within this package because it's an Ethernet GNSS, and it delivers us the PTP timing protocol, which is a great advantage to glue the exact heading data onto the ADCP data. So we have perfect timing using the advanced navigation unit.
Okay, I'll read the next question. Does the center beam in the 250 have the same capabilities and resolution as in the 1000 and 500?
No, unfortunately not. I think for Thomas, it has a bigger resolution. It's around 37 centimeters. That's the minimum resolution, but it also has a greater depth.
Okay, I'll just read the next one since I think it's probably going to be for you, Herman. Is there a suggested depth of the ADCP when towing pole mounted off the vessel to avoid bubbles and other noise?
Yeah, the typical mounting depth is like 60 centimeters. But if it's bad weather and a pretty bad sea state, then you have lots of air bubbles from the breaking waves in the water column. And then you have to stick it deeper. So you have to stick it up to a 1 meter, for instance. And that's typically for pole mounted units. Yeah. Okay.
And then a follow-up from Michael. So we would need to purchase that GNSS antenna. Cannot use our Hemisphere V500.
No, the Signature Coastal is sold as a package. So if you purchase a Signature Coastal unit, it comes with this this unit. That's correct. Is it possible to use the Signature VM250 alternatively as a bottom-mounted wave measurement system? And which extra accessory do I need? Well, that's possible, yes. And the only thing that you need is actually a wave license if you want to measure wave height, and a battery canister. So you can just connect an external battery canister, and you can click and go.
Are the deck box and GNSS the same as for the 1000 and the 500 VM?
Yes, that's correct. So if you in theory, if you have a 500 or a 1000, you can swap them. Yeah, it's the same. And the deck box is also the same for the Ocean series, by the way. Yeah.
Is there a version for USB?
Yes, there is a package for the USB, which is without a PC inside. So it has a connection box, and it's made smaller, so it fits in the USB. And there is also a special USB software So, and this USV software is made without a graphical interface. So it requires just a small computer, a light running processor capacity, and it has the opportunity to make average files. So you can transmit that via a low bandwidth connection. So let us wait. Let us wait just a couple of seconds. Maybe another question pops up. I think we have them answered all.
Yeah.
Yes. It seems there are no more questions, so I'm going to wrap up. So thank you, Herman and Maeve, for giving this nice presentation. And if you do have any further questions, you can always send Maeve or Herman an email. And also, if you're interested in the informative call that Herman just spoke about, please visit the page insight.nortekgroup.com/SIG250-call. Or you can just make a screenshot or click the link in the chat box. And yeah, register over there. So that's it for now. Thanks again all, and we hope to see you next time.